Assalamualaikum. My name is Ahmad Kamal bin Ishaq from class DBN 3A. For this video, me and my crew want to present about datum and runout tolerance. So, for introduction, datum is a reference frame for location point on Earth's surface, while a spheroid approximates the shape of the Earth. A datum defines the position of the spheroid relative to the center of the Earth. All coordinates are different to a datum. A datum describes the shape of the Earth in mathematical terms. A datum defines the radius, inverse, flattening, semi-major, and semi-minor exist for an ellipse. Okay. Meaning of datum is mean singular of data or a single piece of information. A datum can be a point, axis, age, plane or surface. Datums mean a reference from where all other entities are established or measured. It's also a single strand of information and a center. So, meaning of datum in engineering is datum are primarily controls of other dimension. They form the theoretical exact plane, axis or point that GD&T dimension tolerant. GD&T is an international language used to describe a part accurately. It's comprised of symbol, rules and definition for defining a geometry or mechanical part. It has many benefits like uniformity in drawing, better design, no assumption, large tolerance is also used especially in the manufacturing sector for dimensioning and tolerancing. Okay, then introduction for runout is in GD&T, runout tolerance is used to control the location of a circular part feature relative to its axis. Runout tolerance can be stated by two tolerance zones. They are circular or total runout. Runout tolerance are three-dimensional, especially part that rotate. A part must be rotated to expect runout. Both circular and total runout reference a cylindrical feature to a center datum exists. The material condition apply the feature being controlled and the datum feature of feature is always RAF because 360 degrees rotation is required to conduct the inspection. Circular runouts mean a single element measured by their indicator in a fixed position, while part rotate each measurement of multiple elements evaluated separately, and largest reading is the circular runout for the part. Okay, for explanation of datum have three types of datum. One is datum axis. Datum axis is derived from datum feature such as hole or cylinder. Two is datum plane. Datum plane is derived from datum feature such as surface. Three is datum center plane. Datum center plane is derived from datum feature such as slot. Okay, datum feature are selected from real physical feature on the part such as hole, surface or slot. One is functional and interrelationship. Two is representative of mating part or alignment surface. Three is accessible, repeatable from one operation to other operation. 5 is assembly requirement. Okay. Simulate datum is a datum feature simulator is the manufacturing of inspection equipment contacting the datum feature of the part. Datum feature simulator are used to establish the simulated datum. Example of equipment is surface plate, V block, parallel bar, pin gauge block, and angle plate. Okay, this is how datum symbol is applied to holes. Okay, and this is datum feature symbol. Notation is important on drawing. Okay, for example, on a surface. Okay, the symbol must be placed on a with one single extension line out of the datum surface. This means that the datum is only on the surface of the part where it is shown. If it one on side of a rectangular object like a box, the datum surface is only the side where the symbol is shown. However, if the part is round like a cylinder, the datum will be the entire surface of the cylinder. Okay, this is an example on axis. For axis control, the symbol must be placed on the dimension of diametric tolerance. Diametric tolerance as shown above. This means the datum is actually the central axis through the future and not the future surface itself. This type is common with any GDNT symbol that can have axis control right, like runout, perpendicularity, or concentricity. Okay, then for example, on a point or hole is this to establish a datum axis of a feature such as hole. The symbol can be placed in a few ways. Placed directly on the hole, example A in the above drawing. Placed on the ladder pointing to the hole, example B. Placed on the feature control frame itself, example C, shown on the side view by denoting the axis.
Hai, Assalamualaikum dan selamat malam. Nama saya Muhammad Akramuddin bin Muhammad Taha daripada kelas GPN 3A. Okay, hari ini saya ingin menerangkan tentang datum dan juga runout tolerance. Okay. Types the placement of datum future symbols. Okay, nombor 1, surface outline. Second is extension line. The third is dimension line, and fourth, feature control frame. Okay, datum reference frame. Okay, the purposes of the datum system is to limit the movement of a part so that repeatable measurements can be made during inspection. Okay, second is in order to restrict the 6 degrees of freedom on a part with planar datums. The third, the datum reference frame provides directions as well as an origin for dimensional measurement. Okay, every datum is within the context of some datum reference frame. In practice, we must eliminate 6 degrees of freedom before we can fully locate and orient a part within a datum reference frame. Okay, controlling 6 degrees of freedom means controlling 3 linear distances from datum plane to establish an X, Y, and Z position, and controlling 3 rotary position to orient the part at that position. We refer to the translational degrees of freedom as X, Y, and Z. Okay, next is contact point of datum. Okay, consists of 3 datums which are perpendicular to each other. First, primary datum. Second, secondary datum, and the third is tertiary datum. Okay, the next is the 3-to-1 rule and points of contact. Okay, the first is the 3-to-1 rule defines the minimum number of points of contact required for a part datum feature with its primary, secondary, and tertiary datum planes. It only applies when all three planes are used. The 3-to-1 rule says, first, the primary datum feature has at least 3 points of contact with its datum's plane. Second is the secondary datum feature has at least 2 points of contact with its datum plane. The third is the tertiary datum feature has at least 1 point of contact with its datum plane. The last is the 3-to-1 rule only applies to planar datum features. Okay, the next is datum target. A datum target is either a point, line, or area on a workpiece. The datum target is to be the place of contact supports of the workpiece for the manufacturing and inspection equipment. When a part has an irregular contour, casting, forging, sheet metal parts, and the others. The use of a datum target could be required interpretation of a datum target. Okay, type of datum target. Datum target point indicated with a cross. Datum target line indicated with two crosses joined by a line. The next is datum target area indicated with a hatch area within a double dash change line. Okay, the next is three-plane datum system. Normally for orientation tolerances, the use of one datum or two are sufficient. Sometimes when using positional relationships, a three-plane datum system is required. In a three-plane datum system, all the planes are perpendicular to each other. Okay, next is runout explanation. Okay, runout is how much one given reference feature or features vary with respect to another datum when the part is rotated 360 degrees around the datum that exists. Runout symbol. Okay, runout is divided by 2. Okay, the first is circular runout. Circular runout, it has one arrow only, and total runout is 2 arrow. Okay, drawing call out. I can extend it as sketching, a simple sketching. Okay, then the functional applications. First is balancing, second is vibration, and then concentricity, control due the rotating mass. Two types of runout tolerance. Okay, first is circular runout. Provides control of circular elements of a surface. And then one more is total runout. Concerns the runout of a complete surface. Okay, next is GD&T tolerance zone. Two-dimensional circular tolerance zone is that defined by a datum exists where all points on the called surface must fall into. The zone is a direct reference to the datum feature. Runout is the total variation that the reference surface can have when the part is rotated around the datum's true axis. Basic dimensions. Basic dimension is considered a theoretically exact dimension. All a basic dimension does is telling you where the geometric tolerance zone or datum target is located. Look for a geometric tolerance in a feature control frame related to the features being dimensioned. The basic dimension originates from the datum. The basic dimension is enclosed by a rectangle. Basic dimensions are used to establish the true profile, which a profile tolerance will then control. So if a profile tolerance is applied to a hole, the diameter must be a basic dimension.
Hi, my name is Sharik Mami Saleh. Today I want to present about Datum and Runout. I will continue with my friend. Okay, my part is future control frame. In this slide, you can see a future control frame. The backbone of GDT modified as a part geometry. In this slide, you can see a part of GDT. They have geometry tolerance, characteristic symbol, diameter symbol, demonstrate tolerance, future tolerance, modified, and datum or secondary datum which modified. And last, they have primary datum. Okay, next. What's the place of datum in identification symbol and the features control frame for straightness, perpendicular, parallels, and angularities? Okay, I will translate about this. When applying the above two features of size, the placement of the symbol or callout can greatly change the meaning. If the symbol of control is associated with the size dimension, the future axis of center plane is being identified of controller. If the symbol or controller is associated with the surface or the feature of size, it is identified of controller the surface, not the axis of center plane. In the following example, both of datum feature symbol and the perpendicular apply to the feature center plane. Notice that there are two center plane on the next slide. Okay, this is a runout. Runout is a composite control. It controls the form, location, or orientation of a part feature. If it is often used to control the causality of diameter. Control is always applied to RF. Runout also control is divided into two: circular runout and total runout. Runout control require datum and thus require modification. Okay, next slide. About a circular runout. It is a composite control which affects the circularity, orientation, location of the element individual of part features relative to a datum. It is applied independently to each circular element. The tolerance zone is two coaxial circles with center located on the datum axis. Last, the tolerance value is equal to the radius distance between the two circles. Okay. Next slide is a total runout. It is a composite control which affects the cylinderity, orientation, location of all surface elements of a diameter relative to a datum axis. The tolerance zone is a two coaxial cylinder. The tolerance value is equal to the radius distance between the two cylinders. And last, it is very far much similar to circular runout. Okay, next slide I will tell about runout, circular runout. It is a control circularity, orientation, location level. The tolerance zone is a two coaxial circle total runout. Control cylinder orientation crossing about, and the tolerance zone is a two coaxial cylinder. Runout is about 3 detail I find Next is similarity between circular and total runout. First, verify which the indicators. Second, consider as composite control. And third, maximum exit offset 1/2 of runout value. Okay, in this slide is about JDT symbol. You can see about many symbol in this slide. They say geometry characteristic tolerance symbol are categorized in two ways. It's about touch or tolerance. He have individual feature, individual of related feature, related feature. And also no datum of datum needed depending on the situation, and a datum or datums are required. And okay, in this slide is about machining that used for JDT. In this slide you can see a picture of JDT. It has laser tracker, optical tracker, scan arm, scanner, laser projector, and CMM. If you not understand, you can find in internet. And the conclusion is JDT is the modern language of engineering drawing. Its usefulness goes but beyond the topic discussion in the article. It is more involved than conventional tolerance, but tends to be more conscious and powerful. The proper use of JDT can save money and time in manufacturing, while at the same time improve product yield and quality. When the JDT system is used properly, it's reduced. Okay, that's all of me. Lastly is a reference you can see, and you can save that. I received from there. Okay, thank you, and sorry about for my language.